So this is the intro slide, Capstone. This is my introduction. Like I said before, um, you guys have known me for 2 years, and I'm a little bit quiet, but I'm always around. Um, but like yeah, my capstone is on NLP, natural language processing, and the history is because I was kind of interested in multimodal chatbot and chat GPT and all like because everything is using NLP right now. All the big companies are doing a lot of intense research in that. So I was kind of interested in that. So my capstone goal was to use NLP to create a chatbot which can analyze a data set, text, and kind of like not just make a summary, but make a generative summary, like a new content. So next slide, please. And this is the table of content, the introduction, the data and overview, the EDA, the problem statement, methodology, the pipeline, which is RAG, the evaluation matrix, the result, discussion, interpretation, the more on RAG and future documentation and strength, and conclusion and question. Next, please. So why did I choose the topic? Like I said in my brief introduction, like AI kind of hallucinate a lot of time. The more advanced the model gets, the more it hallucinate. 48% of the time, anything you put on GBT or anything hallucinate. Um, then if you use it quite often, if you encounter more hallucination, then the prompting techniques also lead to more hallucination. So hallucination is pretty much everywhere, and even though GBT might be confident in its answer, doesn't mean that it's true. And but the good thing about GPTs and chatbots is that they don't offer as much data leakage, meaning like your data is kind of secure because they don't save the data in the server unless like you're supposed to train them with your data set. Uh, Next, please. So, oh, sorry. So the goal outcome is to, sorry, can you please go back? Is to like build a simple chatbot and zone in on a little bit of hallucination based on the type of data set, structured versus unstructured data, which will be done using word embedding to determine like semantic coarseness, which is like how similar the words are when the chatbot response, and in temperature, which is like the novelty of the word it creates. Next, please, sorry. So my data and overview, the source from GitHub can also be found on Kaggle. It's a medical abstract data set. The text file has 17 million characters and 2.6 million words. So the challenge is like running the old text data set, which is kind of massive because you have to chunk it. Um, and and the data is kind of unstructured, can also present a potential problem if expression is not used, which get rid of like special characters and stuff. Uh, so so the reason so what I did to circumvent this is to simplify my data set and and use embedding and chunking. So the goal again is to analyze a medical data set that is kind of unstructured to infer the capabilities of RAG uh, while creating a chatbot and compare the bot generated response to the ground truth, which is like the original data in the data set. Uh, Next, please. So we have some EDA. So for my EDA, I use I think this is count vectorizer and TF-ID vectorizer. So I think count vectorizer just tells you how much the frequency of the word in the first 1500 sample of my data set. Taking so it picks up pretty much any word like there and it just puts it in a pie chart. Then the TF-ID vectorizer, which is down here, that represent like I don't know, like a graph, like a scatter plot-ish. Um, what it does is that it scores the word and it gets rid of like it scores the word including like redundant words such as like off and d and in and a little bit of like irrelevant words, but it gives it a TF-ID score. But what you can do is that you can actually filter these words out, and I think I did that, and you can modify the score. So this is pretty much some ED I did on my data set. Next, please. So my problem statement and motivation. So like I said, it's a create a chatbot and implement NLP such as RAG, which is a core concept in the in our program in the program. And this matters because AI generates revenue for companies in our sector, cutting time, saving costs, improving efficiency. So the AI role is not to replace the need for human interaction, but to assist in optimizing decision making as data become more vast and too much to handle. And that's just some financial. So CNBC, they did estimate last year that OpenAI, so the creator of ChatGPT, were to generate $12 billion by the end of 2025. Then Anthropic, I think that's Claude, generates about 3 billion in annualized revenue. So the market is there, definitely there. So the objective to be create a cool text chatbot that will be hosted on Hugging Face and test the functionality, then run some evaluation metrics, then discuss the importance of RAG in text chatbots, and suggest some improvement and limitations. So this is my flow chart. So like you said, EDA first, then API model, which is gotten from OpenAI platform, but you can also use any, well, you can use Google and Google AI Studio, then chunking, then embedding, then storing the vectors and prompting, then evaluation, then hosting on Hugging Face. And so the reproducibility is that the code after my presentation I can put that on GitHub and for other people to run to verify. And so the evaluation matrix can be used to determine hallucination of models. So human metrics should also be incorporated. So just a human, just I guess like verifying the information the output the bot responds to, and you can we just run some simple code to see how they got the exact information. Next, please. So the rack pipeline. So after reading my data set, using word frequency, count, and TF-ID, then I did the API model. I used like I said, OpenAI platform to generate an API key. Then there's the GPT, which is stands for I think is generated pre-transformer. Um, it has different types of model you can use based on like advancedity, and that model do actually can affect hallucination. But there's also chunking. Chunking will be done using FAIS, which is a Facebook, I think, algorithm semantic similarity to chunk it to 250 size and a 10 chunk overlap. And which will be done using a recursive character text splitter, then embedding, which is to convert the text to numerical variable using vector embedding, then saving the vector, um, then prompting with 4 different questions, then hosting it on Gradio, which is like found on Hugging Face, which you can host apps. The other alternative is to build your own backend using JavaScript and some bunch of like I guess server and backend server like C++ or SQL. Then lastly, I'll evaluate, which is evaluation of the bot generated response with the ground truth. So for my eval metrics, I did some bunch of comparison. I did a bot score, a boost score, a rouge score, and then I also did some extra evaluation metrics based on the by importing different module and packages. For example, I did the fallback rate using PyTorch. I did confidence score using PyTorch, current score using DeepVal and perplexity. And this is just a sample score of like one of the prompting questions I did. I think this was prompt 2. Next, please. So the eval matrix. So for the rouge, the scores. Michelle, we'll be going back and forth. Just so bear with me. For the rouge, it was just 0.1, 0.2, which is very low. So I kind of excluded that from my analysis. And Boo also was very low and was kind of excluded. And the reason also being that um, because they work on n-gram matching, so they match word for word. And if you use an LLM, LLM is generating new words, right? So the score will obviously be low, irrespective of how you prompt or whatever you prompt. So those two metrics were just, I guess, thrown out of the window. So bus score takes into consideration one word context. Then there's also coherence, um, which is a matrix used to measure the correct and flow of sentence structure in generated chatbot response. Then there's perplexity, which is used to measure the ability to generate novel words, often tied with temperature. And the fallback rate is to, like, if you put a fallback section to prevent hallucination. So for example, if you don't have the information, you can say, I don't have enough information to answer that. Then you can now calculate the percentage of how often it did this. So the fallback rate is the number of times this statement is used. So for my result, so as the table on the left shows a bus score, precision, recall, and F1 score for all four prompted questions. Uh, we got we I guess like discredited Rouge and Blue because they're bad for the evaluation for LM chatbots, based chatbots. So we did the precision for um the first question and the second question and third question, fourth question, and its the precision is pretty high. The F1 is also kind of good, and the recall is there. So the F1 is obviously the best matrix because it balances both precision and recall. So this is just a table showing the score for the BUT score um, for all the four prompted questions. So the key report was that the BUT score I the BUT score was used to assess the quality of tests and the semantic closeness retrieved by RAG. The reason this is useful in understanding not just retrieval, but what context and generation. So the BET score outperformed other evaluation metrics in evaluating similarity between a chatbot generated response and the ground truth. Next, please. So this is just a little bit of insight. On the left, you can see a screenshot of the question I kind of prompted it with on Python. So then the answer is just given to you right over there. So the result insight is just to say that um, each prompt will always obviously have a different precision and recall and F1 score. This is because the best score is actually is based on semantic closeness, which is contextual. And because you're prompting different questions and it's generating different response, even though you prompt the same question again to generate a different response, technically, it's not going to use the word exact word match word for word. So this will always obviously be a little bit different. Not totally different, but a little bit different. So the coherence score of the second question was found to be 0.897. A perplexity score of 146 was found using a GPT-2 large model, and all the evaluation metrics points to that the chatbot performs well when analyzing text data and generating response. Next, please. So this is a comparison with some of the bot generated response and the original data set. I'll go into the demo, which is going to be like 1 minute or so. So as you can see, if I prompt a question, I did prompt a question saying like what were the number of subjects in the hypoplastic polyps um, colonos colonoscopy test, and it should give you 185 subjects here. And you can do the same thing over here. You can just verify from the data set, and you can see what the bot responded to, and if it's actually correct or not. Next, please. So zoning on RAG. So RAG and hallucination. So RAG is probably one of the major causes of hallucination. And why is it that? Because like for my research, prompting, doing reading, and also asking Gemini, um, it kind of zoned it down a couple of things that, so for example, RAG picks up on semantic closeness, which is words or phrases, even though those terms are used in entirely different or misassociated contexts across different paragraphs. So the bigger your data set, the more likely it's going to hallucinate. Then there's also the nuances, which is that the embedded models are designed to understand the meaning of words and phrases. However, context though is very different. And there's the misassociation problem. So if an LM algorithm is either similar, but contextual misassociated chunk after the chunking, then it tries to just synthesize an answer from all of them. So because they're so similar and it's just like you chunk different things and it's in a lot of similar chunks, then it's just gonna like like summarize all of them together. So this can lead to conflicting information, loss of specificity, and pseudo hallucination. Next, please.
Isaac, we are running out of time. Please
All right,
finish it in 2-3 minutes. Yes,
all right,
please.
okay. So this is just the potential cause of hallucination. So text challenge, schema misinterpretation, misassociation of values, and granularity issues. There's a native format and there's a richer context. So these are some of the potential cause of hallucination. So next, please. Uh, so the ethics. So why is this very important? Because of the privacy. The question of data poses risk. It's because it's using LM. The chat log could be sensitive of personal queries such as mood and emotions, and it needs to be analyzed. It needs to know when to report or flag for safety concerns. There's also the risk of hallucination that can be detrimental. So, for example, there's something called AI-induced psychosis, which has led to some suicide incidents. There's also the ethics implementation, which is to prevent the chatbot from making unfounded assumptions when prompted with queries requiring professional expertise. And like for example, like chatbot very much hallucinate most of the time when it comes to legal matters. Um, then also the fallback rate to prevent like hallucination. So my strength and honest reflection is there's huge tremendous benefit of AI to improve efficiency. AI chatbots struggle with they really struggle with established facts. So like facts, but when it comes to like generating information, they do struggle, and there's always room for improvement. So my final analysis is that AI is a useful breakthrough in the computational field, with like how some drugs were reinvented modern medicine. So next please. And so recommendation. So my recommendation is to educate users on prompting techniques. There's some websites that do provide the best way to prompt. Then there's also self-initiatives to learn about prompting, which helps in reducing hallucination. So future work and improvement, advanced chunking. So um, hybrid searches and query expansion. Main takeaway of this project was to build a chatbot and investigate the use of RAG and LM. And the identity, the retrieval component, the project identified the retrieval component as one of the major sources of hallucination. And some of the recommendations is what I read prior to that. So I think next please. So the workflow and citations here, and I think that should be it. Next please. So thanks for your attention.